Decision structures are used so that your program doesn't have to do the same thing each time it is executed. They basically answer a question on the spot during execution. The decision structures need a question to answer, and this is done through booleans. Now, as we've seen before, a boolean is one of several primitive data types, which are essentially raw data. A boolean represents two values. It's either yes or no, in coding terms, true or false. They can be assigned directly, but are usually constructed from a set of many operators. And these operators include, but are not limited to, relational operators and logical operators. Let's look at the relational operators. We can use the greater than, the less than, the greater than or equal to, the less than or equal to, and not equal to. So we can use these operators now in what we call Boolean expressions. So the following table gives us some expressions as examples. For example, I could ask the question, is x greater than y? Is x equal to y? Is x greater than or equal to y? So these now form the type of questions we could ask in our coding. We will look at them a bit later in the video. Now look at the table for our logical operators. We can use the AND, the OR, as well as the NOT operators to connect two Boolean expressions into one. For the AND operator, both expressions must be true for the whole expression to be true. For example, if I have the following expressions joined by the AND operator, I would ask the question, is 5 less than 4 and is 7 more than 5? Now we know 5 is not less than 4, so the first expression would be false. Even though 7 is in fact more than 5, the answer to the whole question here would be no or false. So if I change it to 5 less than 6 and 7 greater than 5, then both sides of the AND operator are true, which will make the whole question true. Now the OR operator also connects two Boolean expressions, but in this case, one or both of the expressions must be true for the overall expression to be true. Let us ask the same question as before, but now let us use the OR operator. 5 less than 4 or 7 greater than 5. In this case, 5 is not less than 4, and that expression would be false. So the left side of the OR operator is false. Now 7 is more than 5, so the expression on the right side is true. This gives us false or true, which will make the whole question true. The NOT operator reverses the truth of a Boolean expression. If the expression is true, then not true would be false. If the expression is false, then not false would be true. So let us look at some examples in coding. Right, so in IntelliJ, I'm going to declare a few variables here. So I'm going to declare an integer x, and I'm going to assign it the value of 5. I'm going to declare a y, and I'm going to assign it the value of 6. And let's use p there, and let's assign the value of 7. Now, let's also create a Boolean variable, and I'm going to call this one expression. This is the Boolean expression that we want to test, and I'm going to assign it a value. So at this stage, I'm just going to say x equal to y, and just leave it as it is. And then what I want to do is to print out to the screen whatever my expression's answer would be. So now you can see it's a normal variables. It's an x, a y, and a p. It's 5, 6, and 7 assigned to them respectively. And then I have defined an expression variable of type Boolean. It's called expression, and then on the right hand side of the equal sign there, I will place my expression. Now in this case, you can see there's one equal sign there and there's two equal signs there, so just don't get confused with the two equal signs there. So the right hand side is an expression. You're testing, you're asking a question, and that's why there's two equal signs. The single equal sign is assigning a value to a variable. So in this case, that equal sign is assigning a value of 5 to the variable x. This equal sign is assigning a value of 6 to the variable y. This one is also assigning whatever the outcome of the question we ask on the right hand side will be assigned to the expression variable. Now remember, Booleans can only accept true or false, which means that when I print out this, it should either be true or false. So we can see there when we print out, it gives me a false. Okay, so what we're testing here, on the right hand side, we're basically just asking a question. We're asking the question, is x equal to y? So in our case, 5 is not equal to 6, and that's why it gives me then the answer of false. So let's change this, and let's say it should be, is x less than y? So is 5 less than 6? Yes, it is. So if we run this now, you will see that it goes to a true value there, because x is less than y. 5 is less than 6. So your expressions will then basically be a question that is asked, and then the answer of that question will be returned. It's either yes or no, or in coding terms, true or false. So let's just try another one there. Let's just say let's ask the question, is x more than p? So in this case, you will see that p is 7, x is 5. So x is not greater than p, which will give us a false value there if printed out. Right, so that is basically just looking at simple expressions. So let's try something else. I'm going to use an x, let's make it greater than y, and we'll put the AND operator there now, and y is less than p. So let's evaluate this question quickly. Remember that for the AND operator, for the whole question that we ask to be true, both sides, both expressions on both sides of your AND operator must evaluate to true. So let's look at both sides. Is x greater than y? Is x 5 more than 6? No, it's not. So on the left hand side, we will have a false value. On the right hand side, is y less than p? Yes, 6 is less than 7. So this side of the operation will actually be true. But because this side is false, we've got a false true, and we need both to be true for the whole thing to be true. So in this case, our expression will also print out false. And you can see it prints out false. But if I change this to an OR, the OR means either one of the two sides could be true for the whole thing to be true. So if I run this now, that because of the right hand side that is true, it will evaluate to true as well. So let's get back to the AND operator there. If I want both sides to be true, I could just say, is x less than y? Is x, which is 5, less than y, 6? Yes, it is. And y is also less than p, because y is 6 and 7 is p. So both sides are now true, which means the whole thing will also evaluate to true. And then let's just have a quick look at the last part there. Or let's just try the OR operator again. So I can go and say, let's say to get the whole thing false, is x equal to y and y equal to p, which means are all the values the same? So let's run this. Is x equal to y? No, they're not. Is y equal to p? Also, no, they're not. Which means both sides of this expression, we have false values now. And for the OR, that will also be false. But remember, the OR, if only one of the two sides are true, then the whole thing will be true. So let's say if x are less than y, which will be true, but y is not equal to p. But if either one of the two sides is true, the whole expression will be true. Now let's quickly look at the NOT operator. So I could have an expression there to say, well, is x less than y? That could be my expression. But then I want to negate that answer, which means I want to change the answer of that thing. If it's true, I want to have the answer as false. And if it's false, I want the answer as true. So the question here is x less than y? Yes, x 5 is less than 6, the y there. X less than y, 5 less than 6, yes, it's true. But now because I put the NOT operator in front of the true value there, it will go to a false value. So if we run it now, you'll see that it will be false. So the not operator basically changes a true value to false and changes a false value to true. That is it for this video. See you in the next one.